Hey guys, first of all, I thought I'd put a little filter on since I'm in science teacher mode. And also, I don't really have much makeup on, so it's a good excuse. Today we're going to be going over Chapter 12, Lesson 1, which is Understanding Chemical Reactions. So hang tight. Okay, so today we're going to be going over Chapter 12, Lesson 1, Understanding Chemical Reactions. This is something that we've discussed a little bit in previous cycles, but we're going to go into greater detail on what a chemical reaction actually is this week. All right, so the first thing we want to review is how matter changes. If you recall from previous cycles, we learned that matter changes in two ways. So it can change physically when there's no new substance occurring. It's just changing in its state. So for example, ice changing to water, or water turning into gas when it boils. Or it can be a physical or a chemical change. That's when one or more substances changes into a brand new substance. So when you take brownie batter and you bake it, and it turns into brownies, that's actually a whole new substance. We'll talk about that more in a moment. So remember, physical, there's no new substance. It's just changing in a physical way. And chemical, you're actually creating a new substance. All right. So what are signs of a chemical reaction? Well, for that, we're actually going to go to your book really quickly. So we've seen these before. There are many different signs that indicate that a chemical reaction has taken place. So there can be changes in property, like a change in color, a change in odor, formation of bubbles, formation of a precipitate, or there can be a change in energy, warming or cooling, a release of light. And you can look at all of these in detail at your own convenience when you do your reading. However, these signs alone are not proof. In order to prove a chemical reaction, you must study the chemical properties. And that's what we're going to talk about today. So back to our handy dandy note cards. So when a chemical reaction occurs, atoms rearrange and form new substances. So remember, we're talking about elements and compounds here. They have a fixed arrangement of atoms. So when we talk about water, H2O is the formula we're talking about. It's always 2 hydrogen, 1 oxygen atom. And that's the compound for water. But when a chemical reaction occurs, that's going to rearrange and change and form a new compound or a new element. So, actually, I want to go back to your book for a second. We're going to talk about bonds breaking. So, if you've done your reading, 421 gives a great example. We're going to come back to this in just a moment. But that gives a great visual. So, for a chemical reaction to occur, bonds must break. So, when particles are moving around and colliding, if there's enough energy, then a bond will break. And if it breaks and rearranges, a new bond is formed. So, for example, here we have our H2O molecules. And if they break and rearrange, they can group up to be 2 hydrogen molecules and then an oxygen molecule, which is illustrated in your book over here. And so it really does a great job of showing how it goes from being H2O to broken up into singular form, and then rebonding in new ways to create new substances. So make sure you check that out in your book. So when we talk about all of this, how do we describe it? That's called a chemical equation. So the description of a reaction using an element symbols and the chemical formula is called a chemical equation. So really quick, I just wanted to hop over to your book. This is on page 422. And this is just a reminder about symbols and then chemical formulas. So it's important to make sure you're using the right symbol and the right chemical formula because if you're getting those wrong, then the entire equation is going to be wrong. So make sure you're familiar with the correct symbol and then the correct actual chemical formula. So for example, the symbol for carbon is C, but the formula for carbon dioxide is CO2, 1 carbon, 2 oxygen. So familiarize yourself with this chart. This is just an example. These are things we've already gone over before, but it's important to get these right before you go on to writing a chemical equation.
All right, so when we write a chemical equation, we have two words we want to familiarize ourselves with, the reactants and the products. So the reactants are the starting substance in the chemical reaction. It's the thing we're starting off with. The products are what we end up with. Very similar to math when we talk about the product. So we're going to do, for a chemical equation, the reactant plus the reactant equals the product. An example of this, carbon plus oxygen equals CO2, carbon dioxide. 1 carbon plus 2 oxygen equals CO2, carbon dioxide. That's it. Now, that's a very basic, easy example, but that's what we're going to start off with. Your book does give you a visual. I'm going to hop on over here. So you're starting off with 1 carbon and 2 of the oxygen and ending up with CO2. Before we go any further, we want to talk about the law of conservation of mass. So this basically states, and this is spelled out for you in your book on page 424, that the total mass you start off with when you're talking about the reactants, the original product, is the same that you're going to end up with after the chemical reaction. So no atoms are lost and no atoms are gained or created. Atoms are conserved. There's an example of this in your book on page 424 if you want to see a breakdown with an experiment they did. We're going to skip that for now for time's sake, but definitely go back and check that out. Another thing that this means is that the same number of atoms on the left side of the equation needs to equal the number of atoms on the right side of the equation. And we'll talk about what that means in just a moment. Let's hop back over to your book again. So we're going to go over a very easy example first. Let's look at this equation. So reactants are 1 carbon atom and 2 oxygen atoms, CO2. The product is CO2, carbon dioxide. Let's look. Are they balanced? Do we have 1 carbon on this side? Yes. 1 carbon on that side? Yes. 2 oxygen on this side? Are there 2 on this side? Yes. So it's balanced. That's very easy. But then when we get to this next example, things become a little trickier. So when we're starting off with our reactants, we have 2 hydrogen atoms and 2 oxygen atoms. And the product is H2O. However, if we look at our original reactants, we started off with 2 hydrogen and 2 oxygen, and the product only has 1 oxygen. That's when an equation is unbalanced, and that's where it gets a little bit trickier. Fortunately, your book tells us what to do in that case, and this is when we want to balance an equation. So balance an equation basically means adding a coefficient. That word should be familiar to you from math class, but if it's not, when we say coefficient, we're talking about this number right here, the number in front of the formula that indicates how many of these. This is different than the subscript, so don't confuse the two. The subscript is part of the formula. The coefficient is indicating how many of these there are. So for this, we're going to go to an example on page 426. Okay, so your book gave this example earlier, and this is one we're going to use to try to balance the equation. So if 1 molecule of water contains 2 hydrogen atoms and 1 oxygen atom, how many H and O atoms are in 2 molecules of water? 2H2O being the formula. So to figure that out, we're going to multiply each by 2. Okay, so looking at the example in your book, and if you haven't read this in detail, by the way, go through and just really study these charts. It's going to do such a great job of explaining it. So we're going over this at a pace, assuming that you've already done the reading. If you have not done the reading, pause it right now and look over this yourself so you can keep up and understand what we're talking about. Okay, so looking at table 2, first we want to check to make sure our formula is correct. And then once we have the reactants and the product listed, we want to check and see if it's balanced. So the reactants, we have 2 hydrogen, 2 oxygen. But the product we end up with is H2O. Well, that's not balanced, right? Because we're starting off with 2 hydrogen and 2 oxygen, and yet we're ending up with 2 hydrogen and only 1 oxygen. Therefore, we need to balance this equation. So how do we do that? Well, we learned earlier that to balance an equation, remember, we can't change the subscript. We can't change this because this is part of the identity. What we can change is the coefficient, that number in front of the equation. So let's look at the left side versus the right side in step 3. Right here on the left, we have 2 hydrogen and 2 oxygen in the reactants. But if we added 2 coefficient over here to the equation, then that gives us 4 hydrogen and 2 oxygen. So the oxygen becomes balanced, but which is unbalanced? Yes, now we have too many on the hydrogen side. So we've balanced the oxygen by adding that coefficient, because 2 times this 1 is 2. But now the 2 times the 2 equals 4. And so we now have an unbalanced formula or unbalanced equation when it comes to the hydrogen atoms. So where can we add a coefficient on either side of this to equal 4 and 4? Well, to do that, we're going to need to add something to the reactant side. So if we put that coefficient 2H2 in front of the reactant side, then we equal 4 on both sides. So I feel like I'm saying a mouthful here. But again, if we go through and read the steps, basically we just want to make sure that we've got the same number of atoms on each side. So if you add it to one side and it balances one set of atoms, but it doesn't balance the other, then you need to go through and add it to the other side as well, so it's balanced. So this 2H2 equals 4 hydrogen atoms. How many do we have over here? That's right, 4, because that coefficient is multiplied by both atoms. We have 2 oxygen atoms over here. How many do you end up with on the right side? That's right, 2. So we have the same number of atoms on both sides. We have balanced that equation. So if that sounded like a mouthful and it was confusing, just remember, you need to add coefficients on both sides if necessary, so that the number of atoms you start off with for each element equals the number that you end up with, because atoms are not created or they're not destroyed during a chemical reaction. So for an equation to be balanced, you want to make sure that those atoms are equal before and after, even if that means adding a coefficient to one or both sides of the equation.
Okay guys, so if you have any questions, you can always email me, or you can just let me know during our next live meeting. Otherwise, I'll see you next time.